Assalamualaikum and good day everyone. So how are you guys doing so far? I really hope and pray that you are doing very well, whether you are in your hometown or at your hostel. Either way, I hope that you can cope with the MCO, Movement Control Order, and always stay at home, stay where you at, and stay safe, and keep your social distance 1 meters apart. Anyway, as you all are aware, I am the second lecturer for this Engineering Mathematics 1, being 11303. So for those who don't know who I am yet, I am Dr. Anida Mutijumani, and I will be teaching you guys on chapter 3 integration and chapter 4 further differentiation and integration. Okay, so let's start our lecture. Alright, hello guys. So we are now in chapter 3 integration. Okay, before I start to lecture, let's have a look on what are the learning outcomes that you should gain right after you complete the chapter. So it is expected that you guys are able to calculate the integrals by using the 4 main techniques of integration. So we do have a very specific methods. Okay, so we will look into it. And second, it is expected that you also able to solve the integration problems, by using integration by trigonometric and hyperbolic functions. So this is another 2 additional methods that you guys need to understand it besides the other 4 here. And finally, on how to apply the integration concept in the application of circuit analysis. Alright, so what is integration? So I'm asking you, what is integration? So integration, is also known as anti-differentiation or anti-derivatives, or it also called as indefinite integral. So, but what it is? So integration we use to find the function by looking or by calculating or by finding from the reverse process of differentiation. So what does it mean? Let me put it this way. You usually being asked to find the velocity of the vehicle. Alright, so one way to find the velocity of the vehicle is by doing the differentiation, or you try to find the derivative of the position at certain times. So that way you conduct the differentiation or derivative to find the velocity. Now, if I ask you how to find the position at certain time, how do you want to do that? So in order for you to find the position at certain time, the position of the vehicle at that certain time, you need to apply the integration. So basically, integration is to find the function which is the position at a certain time by doing a reverse process of differentiation. That is by doing integration. Alright, so the second purpose of integration is we can use it to calculate the area under a curve. For example, for finding the volume, the area, the center of gravity, the moment of inertia, and etc. So this kind of process will lead to another definition, which is definite integral. So basically we have indefinite integral and definite integral. So what is indefinite integral and definite integral? So indefinite integral, we have this kind of function. So I believe that you already familiar with this one. Okay, so basically the fx here, okay, we call it as the integrand. The fx here we call it as antiderivative or primitive. And then what is dx? Dx we call it as integrating agent, whereby c here is known as the constant of integration. And finally the x, so the x itself is the variable of integration. So here I would like to advise you to look at Appendix A. So you would like to have a look from your module at Appendix A, where you can find the details of the basic integrals formula. Okay, so let's have a look some of the properties. Okay, properties. What is properties? Okay, properties to calculate indefinite integrals. Okay, actually we do have many properties for it. Okay, but the main point here that you should at least master it is this example. If you have a constant k, so k can be any numbers, okay, times the function, the integrand here, fx dx. So what you can do is that you can take the constant k here out of the integral, alright, so that you can only focusing on the integrand here. What I mean is that you can focus on integrating the functions that you have here. Only after that you can multiply with the constant once you finish your integration process. Right, this is the first property that you need to remember. The second property is, okay, if you have the sum or difference, okay, you have one function here fx plus or minus another function gx dx. You need to integrate these sum or difference functions here. Okay, what you need to do or what you have to do is that you just split them both. Okay, fx dx plus minus gx dx, as simple as that. Now maybe we can look at example, right, for property 1 here, example 3.1. So if you are given 5 sine x dx, okay, this is a very straightforward example. So you know that 5 is a constant, okay, so you just take it out from the integrand so that you only have sine x dx. Okay, so what is the differentiation of sine? You differentiate sine, you will get cos. But if you differentiate cos, okay, you will get negative sine. Alright, so in this case, okay, I think there's an error here. Let me check. Alright, so there is a mistake here, or I would say not mistake, a typo here. So when you differentiate cos, you should get minus sine x, but here we don't have any negative sign. So what you need to do is that you need to apply the negative here. So the final answer is minus 5 cos x plus c. So I hope you can correct that in your module. Now let's have a look for example 3.2. So for 3.2 is representing the example for property 2. So here we have some example. Okay, we have fx here is ex, and the gx here, the function gx here is 5x power of 4. So what you can do, as shown in this property, you can split the function like this, and you can do the integration accordingly. So if you integrate ex, you will get ex as well, okay, because we don't have any power at the x here. And if you integrate the 5x power of 4, you will get x power of 5. So how we are able to do that? Okay, let me check if I can write it down here. Yep. Okay. Alright. Before I explain about example 3.2 further, I would like to mention about this one, the basic process of integration, just in case if you forgot about it. Okay, so let's say if you have to integrate x power of n dx, so what you need to do is that when you try to integrate this one, okay, you need to do n plus 1, alright, over n plus 1. So for example, is n here is 2, so you being asked to integrate x squared, okay, so what you need to do is that x 2 plus 1 over 2 plus 1. So your final answer will be x cubed, okay, over 3 plus c. So c is a must, it's a constant, it can be any numbers, okay, so you have to put it because this is indefinite integral, okay, so you need to add plus c here. Okay, now back to this question. So we have here ex dx. If you integrate it, you will get ex as well, okay, because there's no power at x squared here. So then if you have 5x power of 4, so these are the examples, okay, on how to do it. So we have 5 as a constant, you can take it out from the integrand here, so it becomes only x power of 4 as the main function, okay, so you just straight away plus 1 and then over the power plus 1 here, 4 plus 1, so the final answer you'll get 5 over 5 times x power of 5. So we can cancel this out. That is why the reason you got ex plus x power of 5 plus c. Alright, is that clear? Okay, now let's have a look on definite integrals. So definite integrals, okay, the only things that you will not have to write down is the c, okay, the constant c in your final answer. So indefinite integrals, okay, it has the lower and upper limit. So it can be any constant, okay, any constant, 1, 2, 3, minus 1, minus 5, 10, whatever it is, okay, but it will become as your lower limit, and then the upper limit is something that will be a much higher value from the a, okay. So your final answer will be, once you integrate the function, okay, you need to you will get one final equation, sorry, one final function here, but then you need to substitute or replace the x value here with the value from the upper and lower limit, okay. So basically this is the definition for the definite integrals, okay. So let's go through the example 3.3. So this question asks you to evaluate 6x cubed plus 5 dx, and you need to evaluate from 0 to 2. So 0 is your lower limit and 2 is your upper limit. So what you can do is that you differentiate this one like the way I teach you previously. You can take out the 6 constant here, okay, you take it out and then you just integrate the x cubed. So when you integrate x cubed, you will get 3 plus 1, which is power of 4, over 4. So 4 and 6, okay, later on you can cancel, you can there is a common factor which is 2, so you can reduce it. It will become 3 over 2. So 3 over 2 x power of 4 plus, so the okay, just want to highlight, if you differentiate a constant number, for example 5, if you differentiate, okay, you'll get 0, am I right? But here, okay, since this is integration, if you integrate constant number, you will get together with the constant number another x. So don't forget about that, okay? Don't mix it up, alright? So you'll get 5x. Okay, not a 0, yeah, not a 0. You'll get 0 if you differentiate it, but here we are learning integration. So you just think, okay, let me put it this way, yeah. Just think that this is the original function. I asked you to differentiate it, you will get 5, am I right? So this is integration. So if you are required to integrate 5, you will get 5x. As simple as that. Now, the next step you need to do is that, so this is the final function. So you cannot stop right there because this is definite integral. So you need to substitute the value x here. 24 is here. 10 is for this one. 5 times 2. Alright? Okay. And then if you substitute 0, you'll get both 0. So your final answer will be 24 plus 10, which is 34, minus 0 plus 0. You'll get 34. Okay. Now, example 3.4. This is the trigonometry function, which is cos x dx. Just imagine if you want to differentiate sine, you will get cos. So if you integrate cos, you will get sine. So when you integrate cos x, you will get sine x. Don't forget to put the lower and upper limit here. So by using the calculator, I think this one is in radian. Yeah. So you'll get the final answer as minus 0.7. Okay. Well, these are the remaining here. Number 1 to 5 here are the another properties. Yeah, another properties that you probably might want to know. For example, if you differentiate, if you integrate fx, and the upper and lower limit is the same value. Okay, they are in the same values. So definitely you get 0. Right? If the fa exists. Okay, and if you put a to b, integration of fx dx, if you switch the position of upper and lower limit, so the upper will become the lower limit value, the lower limit become the upper value, limit value. So you need to put the minus sign here. Okay, so you'll get the same answer. And okay, this is the second property that we learned from the indefinite integral. The second property, the sum and difference property. The same thing happened to this, except that we only need to remember the upper and lower limit values to be substituted in the functions later on. Same goes if we have the constant function. Okay, we have discussed this, and also this one. Okay, if you are required to integrate dx only, okay, it means that you will get x. Okay, don't forget about that. If you integrate dx, you will get x. Okay, what does it mean? It means that you actually integrate 1 dx. Okay, so if you integrate 1 dx, it means that you will get only x as your final answer. That means you only substitute the b and a into the x, so the final function will become like this if you want to solve it. Yeah. Okay, now example 3.5, it shows on how to answer the definite integral. So this one, if you recall the previous property, it falls in the first property here. within the different integrals. Yeah, so we have the same upper and lower limit value. You should get 0 by chance. Yep, you should get 0 if you integrating it correctly. So 2x, you will get x squared, okay, plus 5x, okay, and then you substitute 3 and 3 here, you will definitely get 0. Alright, you can try it later on. And here, example 3.6. Okay, example 3.6 is a bit special, okay. I believe that you have learned this function previously in your first chapter limit, yeah, limit chapter. Okay, so what is the function of this? It has a name. Okay, I hope that you are still remember that. Okay, it's very easy to solve this. So we have the absolute, yeah, the function, we call it absolute function. So we have an absolute function which is x plus 2. So x plus 2 is an absolute function because we have the modulus here. Okay, straight away you know that in absolute function there will be a negative and positive function that exist in this function, in this absolute function. Yeah, so you need to know that we also have point of reference here, which is minus 2. So how I get minus 2 here? Simple. X plus 2 equals to 0. So you get x equals to minus 2. So this will become your reference point. Okay. Now we have minus x plus 2 for x less or equals to minus 2, and then we also have x plus 2 for x greater than minus 2. Okay, my MacBook will sleep very soon, so I will try to finish this as soon as possible. Okay, so what you can do now, which function you want to pick? Okay, that's the main question, am I right? The second step you need to do is that you need to, since we know that the cutoff or the reference point is at minus 2, and we have the range here from minus 3 to 5. So what you need to do is that you need to have your function to stop, okay, to stop integrate at the reference point. Okay, so we know that reference point is minus 2. So if I can show here, alright, so if you draw the scale here, so we have here minus 3. Okay, sorry, I need to use this. So you have here minus 3. You want to go to 5. Okay, this is your upper limit, this is your lower limit. But you also have a reference point at minus 2. So that's why you have to split down your function into 2. First, you integrate between minus 3 to minus 2, one function, okay, and then you integrate from minus 2 to 5, okay, another function. So what are the function for these two? You need to refer to the defined functions here. So for x less than minus 2, so x, this is x exists, right? So for any function that less than minus 2, so it falls here. This is less, okay, this is less, right? So this is greater, okay, greater than minus 2. So for any function that falls less than minus 2, you need to use minus x plus 2. So this is minus x plus 2 dx. Now for the second function, it falls greater than minus 2. So you need to take the second function here, which is the positive one, x plus 2. So I believe that somehow you need to you need to delete this one, yeah. It's not minus here. There's no minus. It's a positive function, yeah. So maybe I can add up here the symbol here. Okay. I just erase it so that you I don't want to make you confused, yeah. So erase this one, yeah. So it is negative function for this range and positive function from -2 to 5. Is that clear? So the rest you just need to integrate this. So integrate x, you will get x squared. Integrate this, you will get this, and then you solve it by substitute the upper and lower limits. The final answer you should get is 25. Is that clear? So try to do exercise 3.1, yeah? Alright. Okay, so I think that you guys have at least listened or viewed the video that I shared on chapter 3.1, Introduction to Integration. So now I would like to share how to solve exercise 3.1, but I only picked up 2 questions out of 4. So here is the first question that I would like to solve with you guys. Okay, this is an algebraic expression. Okay, you can refer to page 74, the 2 Roman, question number 2 Roman. So the first thing that you need to do is, alright, okay, maybe I should try to pick the blue marker. Alright, the first thing that you need to do is that since this is an algebraic expression and there are 2 different functions, but you need to product them first. So first thing first is that we expand it. Okay, how to expand it? I guess you already know and learned about this. Put your integrating agent here. Okay. Now next thing is I might wait, yeah, let me check. 2x, alright, and then minus 2x. Okay, so the next thing is 6x squared. So this is 15 minus 2 is 13, yeah, plus 13x minus 5. Okay, now, okay, let me check, double check. You need to always double check your work, yeah. So this is the x. Okay, next, only then you need to integrate it. So 6x squared, you integrate it, you will get this one, okay, plus 13x squared over 2 minus 5x plus c. Why plus c? Because this is the indefinite integral. Okay, now you can simplify it. You get 2x cubed plus 13 over 2x squared minus 5x plus c. So you can try to check the answer. How? So you have your smartphone, you can scan the QR code at the back. I guess you already know. And if I'm not mistaken, the final result is this one. Okay, very simple. Again, if you have this kind of algebraic expression, you need to expand it first. Only then you apply the, well, this one, if you already master it, you don't have to take the constant out. Alright, if you're following the first property in the indefinite integral, you have to take the constant out. But it's okay if you already know how to integrate this one. It will not affect you at all. So just straight away integrate it to get the final answer like this. Okay, is that clear? Now let's move to the next question. The next question, I would like So this one has a limit, okay, lower and upper limit. Okay, the first thing is that we considered first this function. Okay, so we need to know what is the reference point. So for x minus 6, you equals it to 0. Okay, then you'll get x equals to 6 over 4. You can simplify it, you'll get 3 over 2, or equivalent to 1.5. Okay, this is clear, right? Very simple, very straightforward. Now, the next step is that, okay, you need to draw, oh no, before you draw the timeline, okay, not the timeline, okay, you need to define the absolute function first. So for x minus 6, okay, for x minus 6, absolute function for this is actually equivalent to negative for x minus 6 for, okay, x greater, oh sorry, not greater, for x less and equal to 1.5, or positive for x minus 6 if x greater than 1.5. Okay, define this absolute function first. Once you have defined it, okay, the next step is that draw the, okay, you can name it whatever you want. I call it similar to timeline. Okay, so let's say this is your cut-off point, which is 1.5. Okay, this is where, okay, let me change my marker here so that it will become a little bit more clear. So this is 1.5. Okay, this is your reference here. So you look at your limit, it is between minus 2 and 3. So where is minus 2 and 3? So let's define one by one. 1.5 is 3 over 2, right? So 3 over 2, we have here 2 over 2. So 2 over 2 is actually 1. So I just write down 1. And then we also have half. And then we also have 0. Now we go to minus half. This is minus 1. Minus 1.5. And this is your 2. Okay, this is your minus 2, sorry. This is your minus 2. Okay, going further here to the right is, this is equivalent to 3.2, right? So 4 over 2, if you simplify, you'll get 2. So I just write down 2, and then we want to go to 3. So 4, 5 over 2, now this is 6 over 2 is 3. So I just write down as 3. So this is another point, okay, where your lower limit and upper limit situated. Okay, so they are positioned here. So what you need to do, you need to understand where to put this function. Okay, we have defined the absolute function. What is the function will be when the x is less or equal to 1.5, and what will be the function is when the x is greater than 1.5. Okay, now we only need to write down the new expression for this absolute function. So from minus 2 to 1.5, the function that you need to pick is the negative 1. Alright, why? Because the range for the lower limit and upper limit is between minus 2 to 1.5 here. Minus 2 to 1.5. So you need to pick the negative function, which is negative 4x minus 6. Whereas from 1.5 to 3, you need to pick the positive function, which is 4x 2x minus 6. Alright, so you need to bear in mind that for this type of question, the absolute function question, you may need to have or split the integration limits between the lower limit to the, will stop at the reference point, and then from the reference point to the upper limit value. Alright, so next step is, let me erase this one, since I have to borrow my kids' whiteboard, so the space is very limited. Anyway, I'm still thankful for that. Okay, so next thing, simple, just integrate it. You simplify it, you'll get 2x squared, okay, minus 2x squared, minus minus is positive 6x, okay, right, and this one is similarly 2x squared minus 6x from 1.5 to 3. Now remember the definite integral definition, you have to substitute this value 1.5 here and then minus the next FB. This is FB minus FA, remember? So you will get, if you correctly plug in the value, so eventually your final answer will be 29. Okay, so I hope this example will clear you up on how to solve this kind of question. So don't forget to do the rest of it. Okay, number 1 and number 3 Roman, the questions are very simple to do. Okay, do it so that you will get more or deeper understanding on how to do the integration calculation. Alright, that's all. Thank you.